right. So luminol. We want to talk a little bit about luminol. Try to explain the demonstration a little bit in a chemical way, a little more formally in a chemical way. The process of luminol giving off its light is called chemiluminescence, where the chem means that the luminescence part is, okay, that means emission of a photon, giving off a photon. So electrons moving from a higher energy level to a lower energy level. And the difference in energy between those energy levels corresponds to the energy of that photon. The chem comes from the fact that that luminescence is caused by a chemical reaction. And in particular, the chemical reaction that's going to happen is what we're going to call is the oxidation of luminol using peroxide. And so what we have here is we have peroxide and ferrocyanide. We have luminol and sodium hydroxide, and when we mix those two things together, you end up with that brilliant blue color that is produced. Now, it probably isn't right. The ferrocyanide peroxide mixture certainly is a bright yellow color, where the luminol and the sodium hydroxide is a not. Is not. So the luminol sodium hydroxide is just like a dull brownish color at best. Just if you look at it, you say, "Oh boy, that doesn't look like it's clear, pure water." If you look here, structure of luminol is right there. And there's going to be a couple things that are going to happen whenever this luminol is oxidized by the peroxide, and that is that we're going to produce an oxidized luminol species that's going to have electrons in the excited state. Then when those electrons come back down from the excited state to the ground state, that's going to lead to that blue photon being given off. Now, this next slide is going to be extraordinarily complex. So I thought it was important to describe exactly what happens in the process of luminol being oxidized. And so, this first, 3 or 4 steps are all the chemical steps that occur whenever luminol is oxidized. First of all, it has to happen in basic solution. Bases tend to take hydrogens or steal hydrogens from chemical compounds. All right, it's going to take this one right here. Then we have the ferrocyanide, which is going to be we said that was like a charge transfer reagent, where here it's going to inject an electron into the system. Then we're going to get a reaction with what's going to be called a superoxide species to form this oxygen bridging compound, which decomposes very rapidly to produce nitrogen gas. And then when the nitrogen gas, when the nitrogen gas goes away, we are left with this product, and it's got a little star here where the star indicates that product, has electrons in the excited state. So we're forming something. It's getting energy during this oxidation and rapid decomposition. It's getting that energy, to move that electron from that to that excited state from that process. Then that electron wants to come back down to the ground state, and when it does, it gives off a photon, and that photon in the case of luminol is going to be that light or brilliant blue color that you see produced, and we're left with the oxidized luminol species. Very complex, very complicated. The important thing is to understand we have oxidation of luminol that leads to a product that has electrons in the excited state. And when those electrons come back down to the ground state, when they relax, it gives off a photon, and that photon has that characteristic luminol blue color. And the key for what we have talked about, and remember this goes back to our idea of energy, is that when we produce that compound, that excited state luminol, oxidized luminol species, all right, it's got electrons in a higher energy level. So that compound has higher energy than the ground state version of that molecule. And so the difference in energy between those two different things, those two different compounds, corresponds to a photon of 425 nanometer light. All right, so the difference in those energy levels dictates what color photon is produced during that oxidation of luminol, during that luminol process. And we all know what that looks like already. Here's another picture, a picture of it. You've seen the demonstration already. You start to see that blue glow where that oxidation is occurring and where that relaxation is occurring. Here you can see that light flowing through that coiled condenser, that coiled glass tube. All right, so that's luminol. The idea that the chemical reaction causes the electron to be in an excited state upon relaxation. All right, upon a transition from a higher energy level to a lower energy level, the energy that's lost is given off in the form of a photon, and that photon is blue based on the energy levels of the excited state and the ground state in that oxidized luminol species. So that's luminol, okay?